Hi, welcome once again. So, you are watching the series of real BARC interview questions, and through these videos you will also get to know what kind of approach is required for interview in BARC. BARC interview, as we always say, are different from all other interviews. They are very long interviews. They are not interested in your answers. They are interested in how you reach those answers. They are interested in your approach for particular question which is asked to you. Hence, in BARC, the interviews, as we know, is very long duration interviews, approximately 1 hour. They give you sufficient time. They ask you your 5 favorite subjects, and the moment you say favorite subjects, they will start asking you basic question from them, these subjects, and many times you will come across a question for which you have not gone through that particular question which is asked to you. You have never come across that question in the book or anywhere. Many students ask, sir, what questions, what books we should refer. Actually, whatever books you have already referred for preparation to reach up to this interview stage, these books are sufficient. Now, different approach is required. The approach has to be different for BARC interviews. That comes with the practice, because approach for each question is you have to think, you have to have divergent and creative thinking. As I always say that in BARC interview, you need to be calm, you need to be confident, and you need to be creative. If you are calm, confident and creative, you can score good in the interview. And suppose your approach they like, the approach which you are maintaining, keeping, if they like that approach, then certainly you can score good in these interviews. And interviews are only decisive factors. BARC may you must be knowing, for particular number of seats they call 20 times people. So, for example, there are 30 seats of scientist, they will call 600 candidates for interview. 1:20 is the ratio, and to clear then and get selected, you need to have really good grip on the subject, and approach should also be good. Through these questions which I am discussing with you, sometime you will find that in entire one and a half hour or 1 hour of interview, they have asked you only 2-3 questions, but they keep on digging you down. They keep taking you down into the depth of particular concept, and they check your concepts there. So, you will find through these questions which I am discussing with you, these are the questions which were told to me by my students who went for these interviews, and I am sharing these things with you further. Through these questions you will understand, okay, what kind of preparation you have to do. At least through this question you should know that, okay, this is how the questions are asked. Of different subjects I am sharing with you. I have already uploaded for thermodynamics, strength of material. This is the fluid mechanics question. So, this is relevant for civil engineers, production engineers, chemical engineers and mechanical engineers. Okay, so as I told you, they will ask you about your 5 favorite subjects. The moment you say fluid mechanics is your favorite subject, first question he asked you was, what are important fluid properties? Then you can name couple of properties, what are the important fluid properties. If you say pressure, temperature, volume, they are not fluid properties, they are thermodynamic properties, so do not make mistake. Fluid properties are like density, viscosity, surface tension. So, to name a few fluid properties, we have a density is important fluid property, then viscosity, and when we say viscosity, we have 2 kind of viscosity terms. One is dynamic viscosity, which we write as mu, and kinematic viscosity. And kinematic viscosity is the ratio of dynamic viscosity and density. Similarly, then surface tension is also one of the property, surface tension, and then surface gravity. So, these are some of the important fluid properties. So, the moment he asks you what are the different fluid properties, you can mention these fluid properties, that these are some of the fluid properties, and then from there next he goes. the moment you must have answered, I am not saying what the student answered, you must have answered these properties, and the moment you answer something, he will go next. Tell us about the viscosity in liquid and gases. Tell us something about the viscosities in liquids and gases. As I told you, viscosity, actually if you see Newton's law of viscosity, that is the basic du by dy. This is the coefficient of dynamic viscosity. This is called coefficient of dynamic viscosity, and this is the fluid property. It depends upon the fluid, and as you know, fluid means two things. Fluid means liquids also, something like water, and fluids means gases also, something like air. And the concept of fluid viscosity and concept of fluid viscosity is different for both. The moment if we say fluid viscosity, that is nothing but it can be linked with fluid friction. Fluid viscosity can be linked with fluid friction, but the fluid friction as a concept is different for solids, and for fluids it is a different concept. In case of solids, you know, at the contact surface there are intermolecular bonds which are formed, and that leads to the resistance of motion, that is a solid friction. In case of liquid, the viscosity is because of intermolecular attraction. As we know, in the chemistry we have studied, whenever there is an intermolecular attraction, there is a, you know, fluid attraction among itself, and then fluid particles are not free relatively, they are more free than solid but not as much as gases, so they attract one another. That leads to the, you know, sort of drag force in the fluids. Whereas in the gases it is intermolecular, it is the concept of intermolecular collision. So in case of liquid it is intermolecular attraction, whereas in the gases it is intermolecular collision. Now this particular thing is called drag stress. This is called drag stress, and this particular term is called rate of shear strain. This is called rate of shear strain, yeah, velocity gradient. This is not shear strain, this is the rate of shear strain, and this is called velocity gradient. So what is fluid viscosity? Sir, this is the fluid friction, and in case of liquids, the fluid friction, that means the resistance in one layer of the fluid to flow over another layer, that is because of intermolecular attraction. And all of you will agree with me that because of intermolecular attraction, I mean intermolecular attraction among liquid molecules is more than that of gaseous molecule. In case of gases, molecules are relatively free to drift or move, and hence they keep on colliding with one another, and the concept of intermolecular collision in gases is actually the reason of viscosity in gases. So the cause of viscosity in gases and liquids is different. Now if I talk about dynamic viscosity, which is this, dynamic viscosity is proportional to the temperature rise in case of liquids, because what happens is as the temperature rises, the intermolecular attraction decreases, and hence viscosity also decreases. That concept we know. In case of, you know, viscosity, kinematic viscosity like this, so as we say, mu is a function of temperature. Dynamic viscosity in the liquid is function of temperature, and in gases also it is function of temperature, but kinematic viscosity is relatively independent. Relatively, I am saying it is relatively independent of temperature. Relatively independent of temperature. Why? Because as you increase the temperature or as you change the temperature, not only dynamic viscosity changes but density also changes, and the change of both of these is such that overall change in kinematic viscosity is not significant. Change is there but it is not that significant. So dynamic viscosity, kinematic viscosity mein you should be very clear that when the temperature changes, dynamic viscosity significantly changes. In case of liquid it decreases with the increase in temperature, and gases mein it is proportional to, intermolecular collision increases, but kinematic viscosity is relatively independent. Now in this case gases, dynamic viscosity is inversely proportional to temperature. Now why that is so? It is because as the temperature rises, the gases, the molecules of the gases, they start drifting, moving, and then intermolecular collision is also there, and because of that intermolecular collision, high intermolecular collision, the molecular drift or motion, root mean square velocity decreases. So in case of gases, dynamic viscosity with rise in temperature, sorry, I have actually made some kind of mess here. So it is inversely proportional to temperature and it is directly proportional to temperature. Is a function of temperature but inversely proportional. So as I increase the temperature, intermolecular attraction decreases, and intermolecular attraction decreases, so viscosity also decreases. But in this case, as the temperature rises, intermolecular collision also rises because of the randomness of the gases molecules increase and their collision also increases. Because we know that root mean square velocity of gases is proportional to under root of T. This is also very famous formula. Root mean square velocity, that is the average velocity we can calculate of the gas molecules, is directly proportional to under root of absolute temperature. Now as the temperature increases, as you know, root mean square velocity of molecule increase and hence probability of their collision also increases, and if collision increases, then the resistance to molecular flow also increases. So as the temperature rises, the viscosity rises in case of gases. As the temperature rises, viscosity decreases. So through this question he was trying to understand your knowledge about viscosity and what do you know about fluid viscosity, how it goes. These are the basic questions, right? He is still not entered into the real challenging question. Now he asks you the challenging question. He says that I give you a container, let us say we provided you a container in which we keep water, let us say in the container we keep water, something like this, and then what we do, we start heating this container. We start heating this particular container now. There is a burner and I supply the heat to this container. So this is the container and this is heating of the container taking place now. So what is happening? How shall you draw the graph? Now he says draw the graph between viscosity, dynamic viscosity and temperature. Let us say temperature initially is at room temperature 27 degrees centigrade, then it reaches 100 degrees centigrade. At why I am saying 100 degrees centigrade, because at 1 atmospheric pressure at 100 degrees centigrade the water will start boiling. As we know, water will boil. So the moment heat energy goes inside, as we know, intermolecular attraction will decrease. So what we can think of common sense, because even I don't know what is the exact plot of this going to be. Let us say viscosity at 27 degrees centigrade was mu at room temperature, let us say T naught, and then it decreases to this temperature 100 degrees centigrade. The moment it reaches at 100 degrees centigrade, it starts boiling. Then as you know, when the boiling starts, there is a phase change process now. As the phase change process starts, now there is no more change in the temperature of the fluid, and hence if there is no change in the temperature, the viscosity can be like this. So he asked you that can you plot the viscosity, and as I told you, he will ask you many questions for which you may not be knowing answer. Even I don't know the answer of this, but approach is something which he is going to check. He is going to check what approach will you keep as I increase the temperature, as I change the temperature, how the viscosity is going to change. That particular approach is required. So as I increase the temperature, from the room temperature you reach up to 100 degrees centigrade where the phase change takes place, and when the phase change or latent heating starts, then at that particular time the temperature does not now changes, temperature does not change, and when the temperature does not change, then the viscosity also remains same. So if you increase the temperature now, viscosity remains same, viscosity is not changing. So I think I need to plot a different temperature here, viscosity remains same, even temperature remains same and viscosity also remains same. So I think I need to plot a different diagram here. Let me give you this variation. Now this is the temperature, now this is the variation. So this is the variation which we are going to get. This is the variation we are going to get, and now this is the 100 degrees centigrade temperature, and this is the room temperature, let us say T naught, and this is mu naught. So what happens is the viscosity decreases up to this, and now temperature is going to remain constant. If temperature is going to remain constant, it is not going to change now. So viscosity is also not going to change. So you are going to observe this much of change in basically this particular situation, right? This is how it is going to be. So water temperature is not changing, right? This is what is the change we are going to observe. So with the change in temperature, this is the viscosity which is going to change, right? Now what happens is this is something which we are going to observe in case of water. So intermolecular attraction decrease at 100 degrees centigrade. Now there is no more change in temperature, and viscosity after that remains same. Right? So after that I am not increasing the temperature now. So you can say that velocity is viscosity is going to remain like this only. Now if I next question he asks you, now take the salt water and plot the graph. Now you add the salt water in this. If you add the salt water now, so let me give you the container again now, and this container is again heated, and there is a water and there is a salt in this. When you added the salt, the viscosity increases, intermolecular attraction increases. The moment you add salt, intermolecular attraction increases and the viscosity increases. That is what has happened. So if I am to extrapolate the graph, now this is the viscosity, this is the temperature, this is T naught, this is 100 degrees centigrade, and beyond 100 degrees centigrade does not change, temperature remains same. So in this graph we are saying the temperature beyond this is not increasing. Now it is a latent heating after that. Earlier our graph was this, it was somewhere here, and then it was after this it is going to remain like this. We can say like this is now, you know, temperature is decreasing and then it is at 100 degrees centigrade. This is how it is, right? Now if I add the salt water, what happens is this. If I add the salt water, what happens is this. Let me give you first this graph. This is the pure water graph. Now if I add the salt, what happens is its viscosity is already more. Let me draw with the green now. Its viscosity is more. So this has happened. Salt water also, when you heat it up, what happens is intermolecular attraction decreases and viscosity also decreases. But at the boiling, now their boiling starts. At the boiling now what happens is, at the boiling, in the salt water, the pure water will go out and the water keeps on becoming more salty. The salt in water, have you ever thought why lakes and sea water are having more salt and more salty water than the fresh river water? Why? Because of evaporation. Water, pure water keeps on evaporating and the salt concentration keeps on increasing in the beaker. So what is happening now is, when you are heating it, now it is boiling has started. When the boiling is started, there is a phase change. Phase change means salt is not coming out of the water, only pure water is changing its phase from liquid to vapor, and the pure water is changing its phase, and the water inside the container keeps becoming more salty now, and hence the viscosity of that keeps on increasing. So what I could think of is, for this question, that if I give you a pure water and if I increase the temperature from room temperature to 100 degrees centigrade, what happens to the viscosity of the water and what happens to the viscosity of salt water? Then what you can think of is that, sir, if I give you pure water and if I start heating the pure water, as the temperature increases, the viscosity decreases, but at the phase change, now because there is no change in temperature, so viscosity also becomes constant now. But as now the salt keeps on increasing, salty water mein salt keeps on increasing now, and hence viscosity keeps on decreasing. So that type of concept actually was to be thought of. That is what they were asking you to think. Actually they were checking your knowledge, how it all happens. Then comes, how can I decrease now viscosity? The point is, now suppose I give you a beaker and in that beaker there is a pure water, and the moment you add salt, the viscosity goes up. Now what should I add in the water so that now its viscosity decreases? And the answer is detergent. You know that soap solution, detergent, etc., these actually decrease the surface tension. You know that when you add these things, then surface tension is decreased. Surface tension is cohesive force. Intermolecular attraction must be intermolecular attraction is decreased. That is what surface tension is. Surface tension is cohesive force, and cohesive force is intermolecular attraction, and intermolecular attraction decreases when you add the detergent. That is what the surface tension decreases. And wetting behavior improves of detergent water, wetting of the cloth improves, spreading of the water increase. So spreading and wetting of the water improves by adding detergent because of intermolecular attraction decreases. And if intermolecular attraction decreases, what do you think happens to the viscosity? So maybe when they said what should I add so that I decrease the viscosity of water, what should I add in that? Maybe the answer for that would have been, if I add the detergent in that, then viscosity of that water can decrease. So now how it happens that when I add salt into the water, its viscosity increases, but when I add detergent into the water, its viscosity decreases. And this all phenomena is actually because viscosity is nothing but intermolecular attraction. So this entire phenomena is related to intermolecular attraction, and that is how these two concepts are related. So that was another question asked to him. And as I told you that in the interview of BARC, they will ask you less question, but they will keep on asking you further. Then he said, okay, do you know something about the capillary? You know something about the capillary rise, the formula. Let us say I give you water, and the water, I give you a capillary of particular diameter, and can you give me the formula of capillary rise? If I am not wrong, similar I think this kind of formula is there. I don't remember this formula, but this is a kind of formula, 4 sigma cos theta over rho g d square, something like this. This is a formula. Now what is this rho g specific weight? This is d is the diameter of the capillary and theta is the angle of contact. This is called contact angle, and sigma is the surface tension, h is the capillary rise. Now capillary rise in the capillary of the water, or for that matter fall, because if I give you the mercury, and if I put capillary in mercury, then what happens is, like this this meniscus I should make like this, not otherwise. This is the meniscus. So if I give you the mercury, so mercury may there is fall in the liquid level. This is not rise, but this is a fall. So if this is mercury container, let us say this is the mercury, this is water, then water mein there is a rise and mercury mein there is a fall. What is the reason for that? Water ke case mein angle of contact is approximately 0 degree, and in this case it is more than, if not wrong, this is 130 obtuse angle it is. What is if you see the mercury drop on surface will be like this, and this angle is obtuse angle. But if I give you water, water spreads on the surface like this, and the angle is acute angle. So this is how you define the angle of contact. So if you put water on some surface, the angle of contact is acute, that is approximately pure water quality is 0 degree, and for mercury the angle of contact is obtuse, more than 90 degree, and cos more than 90 degree is negative. Now the question was, how do you draw capillary rise with sigma? And you know what happens? Normally student think that he has asked you to plot H and sigma, and they see that H is equal to 4 sigma cos theta over rho g d square. So that means H is proportional to sigma, and let's plot it, which is wrong. Actually it is not correct. And as you know that we know that sigma of mercury is far more than sigma of water. Sigma of mercury is very high. Surface tension of mercury is very high. That is the reason there is a cohesive force, and because of the cohesive force there is no capillary rise, but there is a capillary fall. Because of high cohesive force in mercury, there is a basically surface tension of mercury is very high, and because surface tension of mercury is high, cohesive force is very high. So H and sigma, if you see, mercury में the height, there is no rise in the level, there is a fall basically in the level. So as the surface tension increases, the height decreases. Actually this is what is observed. As the surface tension increases, the cohesive force increases, because surface tension increases, cohesive force among the molecules increases, and H decreases. Rise is not there, there is a fall. So why it happens? Why this is happening? But formula may it looks like H is proportional to sigma. Now what you forgot is that when you increase sigma, surface tension, intermolecular attraction increases or something, then density also gets changed and theta also gets changed. In fact theta rises, because if you increase the surface tension, something like in mercury surface tension is very high, so as surface tension rises, density also rises in the fluid, you cannot assume it to be constant, and as the density rises, so you know there is a change in angle of contact also, and angle of contact becomes obtuse, and at theta 90 degree cos theta changes from a positive to negative value, so it becomes negative. So if I am to draw the graph of H, it can be like this also. When you say theta is equal to 90 degree, what happens is, if you keeps on changing the sigma, the moment sigma keeps on increasing, at one point of time when sigma is so high that maybe the angle of contact becomes more than 90 degree, and if angle of contact becomes more than 90 degree, then height may become negative height. So this is the positive height, this is the negative height, mercury में it is negative and water में it is positive, so H का variation ऐसा आता है. तो ऐसा variation हुआ क्यों? Why? Because sigma is not the only parameter. The basic things to change sigma is intermolecular attraction. So if you change that, density also changes. So maybe when the intermolecular attraction increases or something, then density rises even more, and maybe theta is also rises. So cumulative effect of that is that variation of H with sigma is not proportional, it is inversely proportional. That is how it is there. Now this was typical question of BARC interview question. They start with very basic questions, they make you think, they make you give the logics. This is a very common mistake which students do. This is one of the trick, this is one of the trap. You call it trap for you, you call it trick for them. This is a trap in which you are given two variables. You are given two variables and you are asked to compare two variables, and our mind is tuned that when we are comparing two variables H with sigma, we keep all other things constant. This is a trap in our mind, this is our mental set. But you forget that I cannot keep things constant. I cannot keep things constant. I cannot say that I will change sigma but density will not change. I cannot do that. I cannot say that. I give you another example of this, which is a trap, very frequently asked question. Reynolds number is rho du by nu. What is rho? Rho is the density. What is nu? Dynamic viscosity. What is nu by rho? That is kinematic viscosity. So I can write it as this also. Now tell me, if he asks you to plot Reynolds number with the density, Reynolds number with density, normally student will plot like this. Okay sir, let's keep this all constant. Reynolds number is proportional to density. This is wrong. And everybody knows that as the density increases, Reynolds number decreases actually. It does not increase. Flow becomes more laminar. That means Reynolds number decreases. So what is a trap? Trap is you cannot change density by not changing dynamic viscosity. Now think of this. As you change the density, dynamic viscosity also gets changed. Maybe when you increase the density, dynamic viscosity increases even more. And what happens is, when you increase density, eventually this term increases, and when this term increases, that means ratio increases, so Reynolds number and density, if somebody asking you to plot, it may be like this, not the directly proportional relation. So this is a very common trap. Because students tend to keep all the factors constant. Actually it is not constant. Other factors cannot be made constant. So in physics you cannot assume irrational things. You need to assume rational things. So this is a very, very common mistake which students do, because they assume certain things. So start thinking that whenever he asks you to plot something, can you assume the things to be constant? You cannot do that. You need to, make an analysis, and then only you can do that. I hope this concept is clear. So as I told you earlier also, BARC interview is different from other interviews. You will be asked to focus on the things. You will be asked to think a lot, and you have to think a lot before you go forward. That is how it is. So BARC interview is all about thinking of various things. That is something which you have to do, and regular you have to you have to continuously think and then give your answer. You should not be in hurry. So as I told you, BARC interview is all about calmness, confidence and creativity. And creativity also comes with confidence and calmness. And confidence and calmness comes with knowledge and practice. So start your mocks with YourPedia, so that at least you get some idea how it all goes. It is very, very important. All the very best. Keep watching all our videos related to actual question asked in BARC. Thank you.